Good afternoon. Thanks for joining us today. Today we are going to be looking at some of the things that I've done for the Raspberry Pi industry. Mainly the object is to construct systems that can take this wheelchair lift and merge it with a variety of different controls that can help to make the operation of the coach more fluent. Here we see what your typical gear shift looks like currently now with Allison. Eventually we can change the gear shift to a touchscreen unit, which would make it more friendly. Here we see example of what a driver will now see in the cockpit with the design. We're going to be working with designing something to control this button, which will be our parking brake, to set and release it, which is plausible. As we see on here, when we start the engine, everything is started. And then you got your gear shift down here. But also, learning how to do this, we can also learn how to add in the other functions for this side of the equation. Right here we see a sample of the driver's cockpit and the seat from looking above. You see that the touch unit would be on his left, the brake and the gas on the floor, and you get an idea of where this would actually sit in the cockpit. We go over and look at it from here with the same design. But here we see the side without it. We see that there would be a place over here for the override, and you still would have your touch screen, and the computer would be accessed from the other side of the panel on your coach. And this is a sample of how this can be put together. You have your touch screen here wired into your Pi or your unit right here, and then you would wire it into a photoelectric unit here, which could also be wired to another, and that would go to a three-way solenoid, which would cause the lines to shift or to switch for your airlines in your coach. Now that's the side of how you would work and operate.
Okay, here's the code we used. It's basic Python commands that we use to type it up, which I'll include later in the video as to how we did it.
In a moment,
Okay, as we'll show you how we got how the LED is going to fire up, and we figured in the dark you can see it. As I type in the codes to activate the light, you see that it turns on. Then I enter the code again to turn it off, and then I enter it in to turn it back on, to flip it on and off, to prove that by sending the signal through the Pi and through the board and the schematic, that we can electricity to other places to control different things in the Pi program.
Here we see the Pi. We have a resistor going to LED, going to ground, and ground going to ground. So here we can see what is being used to power the LED light to the board. Here we see the solenoid actually in action. We substitute a car battery to show you that when the electric is sent through the photoelectric switch, that you could generate enough power to set and release the valve. As he taps against the solenoid to generate the electric, you'll notice that air is switched and goes back and forth, which means it would be
In a real vehicle, the air released and the air would release so the bus can move
but also you could set the brake at the same time, which means by this experiment it is plausible to set and release a parking brake on an air brake vehicle with a solenoid valve in place of the normal traditional air brake valve.